Hi everyone, I'm Binalpreet Kalra from Youth Culture, and today we're thrilled to welcome Erik Lloyd with us as part of the Youth Culture podcast series. We're looking forward to hear about Erik's journey through the university studying systems design engineering at the University of Waterloo and all the exciting projects he's been involved with now, especially through his company, Brink Bionics. So let's get started. How are you doing, Erik?
I'm doing well, Banal. How are you?
I'm doing well as well. So, first of all, we would love to hear more about your journey. I know bionics is a somewhat niche yet very up and coming field that has a lot of room to develop some neat technology through. So, how did you start out on this bionics pathway?
So, I guess I'll start at the kind of the high school level. When I went into high school, I joined my school's first robotics team. And that was kind of the start. I'd always had an interest in robotics and things like that as a kid, building things, motorized things out of Lego or whatever I could find around the house. And when I got to the robotics team, that's really when I started to get serious about my interest in engineering and robotics beyond, fun little side projects at home. And it was mentors through the robotics team and the process of going all the way from a design phase all the way through to building a robot and building something that works. That was really my first step into the world of engineering. When I graduated high school, I actually went first into social sciences. I didn't, coming out of high school, quite have the grades for engineering, so I just kind of floated around for a year. I wasn't sure how I was going to get back on that path. And then after my first year university, social sciences was not for me. Um, I still was very much engineering minded. I spent most of the year learning SolidWorks and teaching myself some programming skills instead of doing my actual coursework. And I played a lot of video games too. So I decided to shift to the Bachelor of Technology program at McMaster University, which is where I did my undergrad. And it's a program within the engineering faculty that's more geared towards hands-on work than theory. So in terms of the weighting of your grades, it's sort of like 60% hands-on, 40 theory, whereas regular engineering is kind of the other way around. Um, and I went through that program. I learned a lot of foundational skills related to engineering in electronics programming, and through going through that program and building up those engineering skills, I developed an interest in prosthetics. A lot of it came from my interest in the science fiction of cybernetic enhancement and human augmentation from playing video games and watching movies when I was younger. And I found an opportunity going through prosthetics to build devices that could one day outperform the human body. That was my ultimate goal. I started my journey doing kind of 3D printing through my first co-op, which was with 3D for MD, which is an organization focused on developing 3D printed medical devices. I worked on some projects during my co-op there, a prosthetic arm project, 3D printed tools that could be printed in space and difficult to access environments. So it was a really cool co-op to learn about all these different ways that 3D printing can be applied, not just in medical devices, but beyond that as well. And when I graduated my undergrad, I did another co-op doing wind energy. So I did a basic contract designing wind turbine technology for a startup in Toronto. And then after that, I was still really interested in prosthetics. So in my final year, as a side project, apart from my actual capstone, I built a bionic arm prototype. I don't have that one here. It's currently stuck in our lab at the university, which is locked down at the moment. But that arm was my first actual step into building a functional prosthesis. It was a myoelectric controlled device. I developed my own algorithms for it for smoothing out signals from the nervous system to serve as a reliable, what was called proportional control system. So the more you flex the muscle, the more the hand in turn would match that degree of contraction. And I used that hand when I went to apply for master's programs through the University of Waterloo. When I first met with who is now my former master's supervisor and my co-founder, Dr. Ning Zhang, I showed him the hand. He was really interested in undergrad student having built a bionic hand and wanted to bring me into the lab. And then that's where my master's started. And then through my master's, I did research into upper limb prosthetics, specifically looking at machine learning and deep learning applications to develop more intuitive control systems for prosthetic devices that required less training than conventional machine learning control systems. And so I really started to shift towards, as much as I like the robotics side, I started to shift towards the biosignal processing side, as that's an area that requires a lot of development and improvement to create human-like prosthetic devices. And from there, we started Brink Bionics as a prosthetics company, working on, and that prototype I do have. So this was our last prototype we did before we stopped working on prosthetics, and it's an 8-degree of freedom prosthetic hand. So it's a rotating and flexing wrist coupled with a 6-degree of freedom hand that allowed the user to swap and replace components as they broke down, because it's one of the major problems with prosthetics. The digits on a lot of these multi-articulating hands are very fragile, so they'll break or they'll wear out over time. And normally users have to ship them back into the manufacturer or take them back to their clinician to get them fixed. So part of the model with this was that the user would just order new components off the web like you would for anything that breaks down that you can kind of fix yourself, like car parts, and the user would swap them at home. And from there, we actually pivoted away from prosthetics, seeing that the market there were lots of prosthetics companies that already existed, building kind of affordable upper limb prosthetics, some with integrated machine learning. So we looked at that market and decided that we needed to focus on something else because we were doing the same thing everyone else was doing. And that's when we pivoted to focusing on human enhancement technology, first starting off in gaming and esports. So that's a long-winded explanation of my path. I wasn't sure how much detail you wanted, but that kind of gives an idea that my path has been a kind of meandering mix of different directions. It wasn't a straight line.
No, like that's definitely like just enough detail. Don't worry about that. Like it's a more of an unconventional path, which is always great to see because it's not always just you go into engineering, you stick with engineering, and now you're an engineer, right? And I love that you explored a lot of different things before you found something that you were truly really passionate about, and I can definitely see that. And then you've like done a lot of different things in it, and explored a lot of different projects, and here you are with Brink Bionics. And I love that you started off as a teenager in high school. And a lot of our viewers are teens and young adults, with many of them going into grade 12 next year, starting to think about their future careers. And that can always be a little overwhelming because I know a lot of people don't know what they want to do. So perhaps you can talk about growing up, what were a few like pivotal moments that helped you to determine your career path?
So I had always known I wanted to do something engineering related and something robotics related. How I was going to get there when I was younger, I wasn't sure, as is evident. But the first thing when I was really, really young would have been my parents just buying me Lego kits as a kid. And that really cemented my passion for just building stuff and being creative. I think there's a lot of people forget there's an important creativity aspect to developing and innovating new technologies. It's not just about the engineering side. It's about the ability to imagine new ways of solving problems. So I think that was kind of, I guess, a pivotal moment for me. But I would say one of the big pivotal moments was joining First Robotics in high school. That was a moment that made it feel like real, like we're actually building real robots. From there, I had some mentors during the robotics and also really helped guide me down a path that actually early on had suggested the Bachelor of Technology program, which is how I knew about it after I did my first year of university. So I had some teachers in high school that were really great for supporting the students along their path, especially for the students on the robotics team. And so I have an interesting kind of anecdote about my high school physics class. So I wasn't always the most disciplined student. I had trouble focusing when I studied and things like that. And my physics class, I just barely passed my high school physics class. And in fact, I think I was supposed to fail the exam, which I would have failed the class. But I looked at, when I went in to collect my grades, I told my physics teacher, I already know what my grade is. I know I've got to retake this class. He said, check. And I looked and he said he gave me the credit for the class. He gave me that 50% pass. And I was like, yes, because what had ended up happening is when I went to university, one of the requirements was having that physics credit for the Bachelor of Technology program. So if he hadn't given me that credit, I would have had to go back to high school, retake that course, and then come back to university. So that was definitely an important kind of point in my path where someone kind of took a chance on me, seeing me do the robotics team and all this other stuff. Although I didn't quite meet the grades, he's like, I don't know, give this kid a chance. And that chance ended up paying off for me. I did much better when I got to university in my physics classes by then. But so those kind of moments, having people around you to help support, people around me to help support me through that path was really important in my early days, as I wasn't the most disciplined student. Now that I would say the next pivotal moment for me was building my own bionic arm and just kind of starting to really build my own side projects. I'd gotten a 3D printer for Christmas and in kind of my late years of university, so I was using that to build projects, to develop new ideas, and that's what I used to build the bionic arm, as well as relying on the medical doctor who I'd worked with for my first co-op to help me print those parts as well. So there was, yeah, I would say there's kind of a number of little pivotal moments, but moments during high school, my first co-op with 3D4MD was a big pivotal moment in learning about 3D printing technologies. And then building my first bionic arm that got me into my master's. Those are, I would say, pretty pivotal moments in my career path.
Right, so let's just take a moment to appreciate that you built your own bionic arm in university. Not many people can say that. That's amazing, and it's great that you've taken a lot of initiative to with the things that you're super passionate about, as well as have a lot of support people around you who believe in you. That's amazing to hear. And I know, but with First Robotics, for example, I'm also part of a First Robotics team, and one of the first things I noticed in grade 9 was like, how can like teenagers build a robot that extends like 7 feet tall, and I'm sitting here from scratch, and that was like amazing to me. And then when you go into the competitions, when you go into the entire design process, and when you're a part of that team from the very beginning up till like the competition season, even if you don't go that far, it's just those memories that you build and those like late nights, and it just makes you more inclined to like that experience and want to pursue engineering, want to pursue this design process as a living. And it's great that you found interest in that. And you're here now. So even if you didn't pass, or you did pass your physics class, but even if you weren't the most disciplined students, your ability to apply your knowledge is definitely, I think, what stands out way more. But I guess we can finally move on to Brink Bionics, the company that you founded. Can you tell us more about how and why you started this company?
Yeah, so originally we started it because as I was coming through my master's, we saw a void in the prosthetics market for, I wouldn't say like cheap, but reasonably affordable prosthetic devices that had greater functionality was available in the market. My co-founder and master's supervisor at the time had worked for one of the big prosthetics companies, and he had seen inside the prosthetics company research and development being conducted. He had conducted research and development, and then that innovation would be shelved because because if they put it in the market, it would compete with their existing products. So they had this ability to build more advanced technology in prosthetics, but they didn't release it to people who needed it because it would compete with their existing products. So we saw this opportunity. It's like, well, why don't we just build a reasonably affordable machine learning controlled arm prosthesis and push that out into the market. And that's why we started Brink Bionics. And our long-term goal was always around human augmentation. This idea of creating technology that far exceeded human performance had been interesting to me for about a decade by that point. I was always fascinated by that idea. that you could swap or replace parts of the human body with robotics that made you stronger or faster. That concept was really cool. And that was our big future goal with that technology, to eventually get to a point where prosthetic technology did outperform a human limb. But as we were going down that path, looking at the competitive nature of the prosthetics market, how the market itself is very, very tiny. Even if you have an arm that costs, $4,000, so really, really inexpensive for prosthetics, most people in the world cannot afford that. Even out of pocket, they don't have insurance. Certainly not in developing countries where many of the limb losses occur in the world. So the market itself is still very small, and there were about 15 to 18 companies all building the same kinds of arms, lower limb prosthetics, some with integrated machine learning. So we looked at that, and then we looked at the money that would be required to get us from here to something that actually matched human performance capabilities in every way. And given the money required to develop some of the most sophisticated prosthetics through the revolutionizing prosthetics program through DARPA, it's a $160 million program to develop more sophisticated prosthetic devices. It's a multidisciplinary problem. It's incredibly expensive to do. We looked at this problem and said, okay, to get to that point is going to require tens or hundreds of millions of dollars for us to get there. It's just not feasible for a small startup to do quickly. Other people with more funding are going to get there before us. So is there another way we can augment human performance in a way that is accessible to a large number of people that we can do now, that has fewer barriers to entry to get into the market? And my co-founders at the time, as a lab research project, were working on detecting muscle signals from a user's hand to see if you can predict computer inputs ahead of their physical movement. And we looked at that and we're like, okay, there might be some application here in gaming and esports. I play a lot of games. I know my reaction time is dropping as I get older. So being able to compete with the teenagers and having a technology that would help me do that would be excellent. So we decided to pursue, I've got one of our version ones here, that with Impulse. So this is Impulse. It's a wearable peripheral nervous system interface that uses muscle signals instead of physical movements to send commands to your game. So you're basically clicking and shooting with neural inputs rather than actually physically clicking the mouse. And it's our first step along that process of augmenting human performance, making you faster using technology.
Yeah, and while researching about Brink Bionics, I definitely came across that, and my gaming knowledge extends to Tetris and Scribble.io, so I don't know too much, but I did read a lot of the reviews, and it had a huge difference between their reaction time, and it's very accessible, and it's not a very bulky product, because I do know that a lot of neurotech technology that you see tends to be pretty bulky, and that's something that people are striving towards reducing. And it's great that within what you were talking about before, it's great that you're keeping in mind while all this technology is coming up and it's not taking over, but it's really helping enhance what we can do with our lives. That you're keeping that accessibility piece in mind, and that's something that I know youth culture finds really important, and it's something that I also believe we need to focus more on, especially if we want to make this technology and help a lot more people. And so it's great that you're keeping that in mind. And with all these cool projects that you're taking on, we definitely want to hear more about your team at Brink Bionics. What kind of skills did they bring to the table?
So my two co-founders are my former master's supervisor, Dr. Ning Zhang, and my CTO, and he's a assistant professor at the University of Waterloo, Dr. Jaiwan He, and then myself, and together we founded Brink Bionics. So in terms of expertise, both my co-founders have been in the field of neural interfaces and neural engineering for I think altogether, the three of us, it's probably about 35 years between the three of us, with Ning having the most experience out of the three of us, and Dr. Jaiwan He having more experience than myself, having gone through his postdoc and his PhD. and focusing primarily on the machine learning algorithms for translating neural signals into controls. So my co-founders are really focused on sort of the pure neural engineering side. And their expertise helps to guide the development directions that we decide to go in. Versus, trying to do research from scratch, we can rely on their knowledge to say, okay, there's a right or a wrong way to pursue a certain type of biosignal or a certain direction for development because of the knowledge they've acquired over the years working in this field. For myself, I have a much more holistic approach to developing these technologies. I have the background in neural engineering as well as the biosignal processing, and I'm constantly reading papers and updating my knowledge, which is really important if you want to be an innovator in the field. But I also, because I like building, robotic hardware and building my own side projects, I have pieces of an exoskeleton all over my desk right now. I take a much more, as I said, holistic approach, a wider spread approach to developing this technology. So when it comes to building solutions into our technology that aren't specifically neural engineering related, that's what I'm focusing on more. So I'm trying to learn more about neural engineering hardware and how to develop better electronics to translate those neural signals and digitize those neural signals. And then basically, when we collect that data, it goes to my co-founders and they sort out, okay, we're going to use these different types of algorithms to translate that data into commands. And so that's the approach that we've taken. So we complement each other's capabilities in the sense that they can focus on the pure neural engineering side and I can focus on how all that technology comes together into a full final product.
Yeah, and this entire like balancing all these different factors is clearly not only applied to technology, but also to your own startup, right? Like you mentioned earlier, you're trying to balance that accessibility piece as well as being able to actually produce this technology and market it and find like and find the entire balance between making the successful company as well as being able to make the product as well as being able to make technology that again considers all these different factors. So it's like that holistic approach I think is very important. And it's great that you're focusing from that, and it's great that your co-founders also bring that like those different perspectives into this company because that will only enhance right your product, and it clearly has. So that's super exciting to see. Um, and I know you mentioned that your two co-founders worked with you were your supervisors, and I believe it was like, was it at the Engineering Bionics lab as well?
Yes, so that's where I did my master's, and that's the lab that Dr. Ning Zhang is director of, and Dr. Jaiwan He is an assistant professor in the lab.
Okay, awesome. So I know that, which is pretty coincidental because I know that when I was applying to the University of Waterloo, I specifically mentioned wanting to work at the Engineering Bionics lab. So I'm quite curious as to how did you get involved with this lab and what has your experience been like, especially considering that you started your company from there?
Right, so I had found out about the lab actually just as it was starting at the university, which is now, was it 4 years ago? Was it? That was 4 years ago. And back in 2017 is when I started my master's. So 2016 is when I sort of in the last semester of school, I reached out to the University of Waterloo. I actually reached out to some other professors there working on machine learning and computational neuroscience. I showed them the bionic arm and they're like, actually, there's a new lab that's starting up with Ning. Excuse me. There's a new lab starting up with Ning. You should check out this engineering bionics lab. So I went to Ning and I showed him this prosthesis, and he was just starting his lab looking for students. And I ended up coming and meeting with him in person when you could do that. And yeah, we talked about neural engineering. It was a really interesting conversation that we had at the time. And he said he'd be interested in being my master's supervisor, and that was like an awesome success moment. So that's how I got in. I got in by basically building my own side project and demonstrating that I had skills beyond grades. As you're coming out of if you're coming out of high school or you're in a university like Waterloo, to put it bluntly, every kid in the room or every student in the room was the smartest kid in the class. And that's the kind of so you need a way of differentiating yourself beyond just grades. I really recommend joining teams, building your own side projects, demonstrating that you've done a literature review, that you've researched technology beyond your courses. Because especially for a lower year student as you're just starting out, you're going to need to demonstrate that you have this certain degree of autonomy when it comes to participating in lab research at that level. So if you can do that and maintain really good GPA, that's going to be your best approach for getting into the lab
Right,
and getting
right.
into working in labs in early university.
Right. Now, in terms of side projects, because that's something that, something that I've been trying to work on a lot more of. But one of the problems that I find with working with these personal projects is, other than getting started, is figuring out what to make and considering like, is it feasible? Is it something that's new? Is it worth making? Am I like going to be able to do it? How do you figure out what you want to do, and then just go with it?
Um, for like my side project's always been like, that's cool. I want to do it. I don't know if I'm going to get it right or if I'm going to make a mistake, but I'm going to try anyway. So like you're absolutely going to make mistakes building your first projects. It's going to be messy. Things aren't going to work properly. It's going to be frustrating, but you're going to learn. I don't always worry if they're independent side projects, if it's necessarily something totally new. I worry if it's new to me. It has to be some way of expanding my skills. So for the first prosthetic I built, it was about understanding biosignal processing. So I'd written a bunch of algorithms that relied on statistical analysis of neural signals to create a really smooth control output for a prosthetic arm. And it was about understanding, okay, how do I build and fit a multi-articulated hand using off-the-shelf motors and parts into something about the size of a human hand? So it was new to me. Obviously, people had done that before. Prosthetic companies have been doing a very good job of that up until this point. But so what I was doing wasn't necessarily particularly new, but at the scale it was at the time, at least I was building it 5 or 6 years ago. 3D printed prosthetic hands didn't really exist at the time. They were still kind of early research projects. So it was somewhat new in that sense, but there was a lot of it that was just new to me. So that's the first thing I look at. Um, and yeah, I don't usually worry about whether I can't do it because chances are I'm going to run into something I don't know. And jumping into a side project, you're never going to be fully ready. So I just be like, my attitude is always, oh, that's cool. Like it'd be cool if I had a powered exoskeleton that was connected to my nervous system. I'm just going to start building it. Um, and that's always my attitude. Kind of jump in feet first and don't worry about making mistakes because you're going to.
I love that, and it's like that requires a lot of confidence, right? And it's great that you had that, and I hope a lot of our listeners, not viewers, our listeners can also take that as inspiration and hopefully start their own side projects that will definitely enhance their learning as well as maybe open up some new opportunities for them. And now just looking at more of the future, we learned a lot about, your journey starting up, starting this new company and a lot of the projects that you've done throughout the years. How do you think your research and your career will evolve in the future? Are you thinking of branching into other fields or sticking to the current bionics kind of field right now?
So human augmentation for able-bodied people or neurotypical people is something I'm really focused on right now because there's that mass market application. So part of the reason I got into this field too is to be able to enhance myself. The idea that I can expand my capabilities with technology has always been appealing to me. So I'll likely stay in this direction of neural engineering and robotics for the foreseeable future. There's other areas I'd be interested in exploring if I had the time and resources, but we'll have to see. I'll play it by ear moving forward. But for now, whether it's through Brink Bionics or other projects, my focus is on augmenting human performance and learning more about the nervous system.
Yeah. And looking into these new kind of areas of exploration and even bionics in general as a career, how can our viewers, so students usually, get involved in bionics? And do you think that this is an in-demand career of the future?
So it depends on what we're looking at for bionics. If you're just looking at bionic limbs, it's still going to be quite niche for the foreseeable future. Although there's lots of startups that are coming up around this technology, there's only a handful of engineers that will actually get hired into those positions. So my recommendation would be not getting tunnel vision on just prosthetics, but on the technologies around prosthetics. So robotics, mechatronics engineering, neural signals and biosignal processing, and basically having translatable skills. So for me, it's my focus was a lot on the neural engineering side in terms of my formal education. And although that was applied to prosthetics, we applied it to gaming, and it can be applied to rehabilitation and diagnostics. So there's lots of different areas I could work in if I wanted to. And if we're speaking about bionics in terms of general human enhancement technology, yes, there's going to be lots of companies that will begin coming up around modifying the human body to enhance performance. Facebook is now involved in that direction. They bought a company in 2019 called Control Labs, which uses myoelectric signals for VR, AR control. And that Facebook obviously is a big company, and they'll likely be growing that technology out in the future. We have Brink Bionics as well, but there's also other companies that will be coming up around this technology, around neural engineering. Neuralink as well, BlackRock Microsystems. There's all these companies that are in this, especially in the research space. But in speaking with my co-founders, I got their feedback on what kind of level of formal education you would need to give yourself the best chance of getting a career in the field of neural engineering, bionics, human augmentation. Usually it's something minimum a master's degree. A PhD would be even better, but at minimum a master's degree is going to give you the best chance of working in this kind of field in an R&D position where you're pushing forward the forefront of the technology within a company or within a research lab.
Okay, that's actually some really good information. Now, in terms of more on the high school student side, other than like some side projects, what about opportunities to volunteer in labs or try to get into opportunities to shadow people at companies, for example? Do you think that that's something that people should consider? Do you have any advice on how we can get into that?
My advice would be for labs, apply to them, reach out to the professors or some of the PhD students in those labs and see if you can get in. I know at the Engineering Bionics Lab, we've had not very many high school students, but we've had, I think, one or two in the time I was there, high school students contributing some work, working alongside master's or PhD students to help with the research. So if you're passionate, just reach out. The worst case is you either don't get a response, usually because they're incredibly busy and they have lots of people applying. But yeah, you won't know, and you won't be able to make that step forward until you take the chance and apply for those kinds of positions. Just reach out, even if there's no formal application online. Just talk to them and said, hey, I'm a high school student trying to learn about X or Y field, and I would love to volunteer in your lab or see if there's anything I can help out with just to learn and be a part of what you're doing. Companies may do the same thing. I found out about my first call from a newspaper article where it was about the medical doctor, Dr. Julian Wong, who owns 3D4MD. She found one of Chris Hadfield's old flight suits in a thrift store, and I found out about her company through that article. And then I just emailed her. I'm like, hey, I'm looking for this, or I messaged her on LinkedIn. I'm like, hey, I'm looking to do this for my co-op. Are you taking students? It was just a chance. I just kind of threw something out in the wind, and hopefully it caught on, and it did. So it's about just finding those kinds of opportunities and not being afraid of, oh, what if they don't respond? What if they reject me? It doesn't matter. You'll never find out if you don't just throw something out and try.
Awesome. That's some great advice for sure. And now kind of moving on to more of the personal kind of side. I'm just wondering what inspires you. We like to ask that to a lot of our interviewees. So perhaps you can talk more about what inspires you.
Yeah, so in terms of my kind of like, I'd always been interested in robotics and engineering, but my initial interest, so when I was much younger, probably around 10 or 11, I watched Ghost in the Shell for the first time. It's a Japanese animated movie, and it's all about cybernetic enhancement and a world where people have replaced their entire bodies with robotics and augmentations. And that was the first time I was like, that idea of modifying the human body with technology, you kind of blend the lines between human and machine I was like, oh, that's really a weird idea, but that's really cool. And then a lot of it was like video games. It was science fiction that inspired my path to make science fiction a reality. And when I was coming out of high school, I played a game called Deus Ex Human Revolution, very much the same concept, a world where people, companies sell bionic limbs that people can go into clinics and swap their limbs, their eyes out for better eyes, their arms out for better arms. And again, I was like, that's a really cool idea. Now I'm more on that engineering path. That's what I'm going to do. But I actually originally made that shift from my original interest was actually weapons development. And I shifted away from that after doing a lot of research on military technology development. I saw more about where prosthetics were. I tied that back to my interest on the science fiction of prosthetics and bionics, and I'm like, we could actually get there in my lifetime. I should focus on this direction instead.
Yeah, that's awesome. And it's great that you bring up so this entire like technology combined with like healthcare, medical stuff, biology, it's like especially nowadays with COVID-19, you see how we're not just trying to get back to normal again. I love how specific companies and specific people are trying to get back to a better normal because you don't want to face these problems again. You want to keep enhancing people's health and people's like abilities, and just so problems like these don't don't push us down as much as this did, for example. And it's great to hear that that's something that inspires you and that's a mindset that you have. And perhaps last but not least, maybe after, even though you've given a lot of advice, what are some of your final words of wisdom for young people out there choosing their careers or trying to get into this pathway?
So my first piece of advice would be, looking at my path, it was very unconventional. Um, I kind of moved around through different fields, and I saw my greatest successes through unconventional paths, through paths that weren't like, oh, I go to engineering, I go to master's, I get my degree. It was more of, oh, if I built this bionic arm, maybe if I show it to this prof, they'll let me in the lab. It was so I would encourage students to not have blinders on when focusing on their career. Chances are something's going to go wrong. Something's not going to go to plan, and that's okay. Sometimes you have to roll with the punches, and you can't plan every hit and every block. So you have to be able to see the unconventional opportunities around you and see them as opportunities to pursue the path you want to get to. Yeah, my other advice would be, working through grades and everything in university is important. A lot of what I found during my undergrad that was really helpful were also the social connections I created. Being able to sit down and study with friends. So if I didn't understand something, I always had someone to talk to. My last semester of exams, all of my friends kind of had different courses that they were better at than others. So we all spent time teaching each other the stuff that everyone else didn't understand. And so I think although studying is important, I see a lot of students who just kind of hunker down, they study, they don't interact very much, they're not very social. Having those social interactions will help your mental health during university, but will also help when you're studying for courses. It's important to have those connections and support structures. So don't downplay the importance of that.
Thanks, Eric. Well, unfortunately, that's all we have for today. We learned a lot about this new up and coming field of bionics. We learned a lot about Eric's experiences starting a new company right out of university, and a whole lot about this incredible technology and a lot of the projects that you've been working on, specifically with neurotechnology and your experience with like as a software developer. And then we learned about how you're all the things you're inspired by, especially by making technology more accessible and, enhancing ourselves and our abilities. And, the list can go on and on. So thank you so much, Erik, for joining us today. And until next time, this is Binal signing off for Youth Culture.